Hello everyone and welcome to Java Lesson 2, Primitive Data Types. Today we're going to be talking about what the primitive data types are, how to declare and initialize them, and what exactly the reason is for having so many different kinds of data types. So first let's start talking about the byte. The byte is the first primitive data type. It is the first one that represents whole numbers, and you declare it by saying byte, B-Y-T-E, and then give it a name. I'm just using B here, and then to initialize it you give it a value. We're going to give a byte the value of 1. So a byte can have a value of from negative 128 to positive 127, and it uses 1 byte of space in RAM. The reason that you would want a variable like this is if you don't have very much RAM, like computers many years ago did not have a lot of RAM, so you had to be very conservative with your programming. And if you had a variable that you knew wasn't going to leave these ranges, like in a loop or something, then you would give it, you would assign it as a byte. That way it wouldn't take up as much space. But what if you need a number bigger than that? Well, there's also a short. A short, you declare it in the very same way. You say its name, S-H-O-R-T, short, and we're going to call it S, and assign it a value of 1. So this short has been initialized at a value of 1. A whole number from negative 32,768 to positive 32,767, and it uses 2 bytes of space. Well, what if you need something bigger than this, or smaller than this? Well, then you use an int, and an int is going to be the most common whole number variable that you use, variable data type. The reason for that is it's got a pretty good range, negative 2,147,483,648 to positive 2,147,483,647. And it uses 4 bytes of space in RAM, and it's just kind of the standard. That's what most Java programs use today whenever they need a whole number. There are a few exceptions, and there are some use cases where you'd want to use a smaller size if RAM is going to be an issue, but most of the time RAM is not an issue in modern computing. Well, what if you need a value that's bigger than this 2 billion, or smaller than this negative 2 billion? Well, you would use a long. A long is declared a little bit differently. You write the name long, you give it a name, which this is an L, and honestly you should never use a lowercase l as a variable. I'm just using it because it's a long, it's an L. And we've initialized it with a value of 1, but you see I've put a capital L. Oh, I've switched them here. I've put a capital L after the 1. The reason for that is if you declare a variable and initialize it as a long, but it's less, if it can fit inside of an int. So if you had a long that was 2,147,483,647, Java will automatically cast that as an int in some cases. If you're using something called method overloading, where you just pass the value as either a literal, or something like that, it will use it as an int value. And then if you need to go above that value, it's not going to work. So you have to put the L afterwards. It's just good practice. I mean, technically you don't have to, but you definitely should. Otherwise, you may get some buggy code and not be able to figure out what's going on. This just forces Java to recognize this as a long, no matter what. Alright, so now we're going to talk about the value of the long, which is enormous. This is negative 9 quintillion, 223 quadrillion, 372 trillion, 36 billion, 854 million, 775,808 to 9 quintillion, 223 quadrillion, 372 trillion, 36 billion, 854 million, 775,807. It uses 8 bytes of space on RAM, so it's twice as big. You can see everything pretty much doubles in size as you go up for these data types. But what, we've talked about whole numbers now, but what if you need a decimal number? Well, then there are 2 different types of data, primitive data types that you can use for decimal. The first one's a float, and it's kind of the same as how the long is declared. You say float, and then you give it a name, f, and then you assign it a value, 1.0, and then you put the f at the end of it. This forces Java to use it as a float, no matter what. A float can be a fractional number with up to 7 decimal places of value of precision. It uses 4 bytes of space. If you need more precision than that, you can use a double, and it's declared the same way. You say double, and the double is named a D, and you say 1.0 and give it a D at the end. Same reason as you do for the long and for the float, so that Java is forced to use it as the variable you've declared, as the data type you've declared. And those are fractional numbers with up to 15 decimal places of precision, and they use 8 bytes of space in RAM. One thing that is interesting is all of these variables that I've initialized here, they all equal 1. A whole number 1, they all equal 1. But they use different amounts of space in RAM. Even though they have the exact same value, because of the data type that they're declared as, they use different amounts of space in RAM. And that's just a nice little tidbit just for you to know, so you can kind of understand why different data types would be used in different places. Now the next data type is called a character, or I'm sorry, it's called a char, but it's short for character, and it's just a single character of text. It uses 2 bytes of space. And the way that you create a character is you say its name, C-H-A-R, you give it a name, C1, we're going to call it C1, and it is equal to a character, in this case capital A, in single quotes. Alright, so another way to declare a char variable and to initialize it is to write C-H-A-R, and we're going to call this one C2, is equal to 65. Now what does that mean? Well, that is the ASCII code for the capital letter A. And ASCII, A-S-C-I-I, is another way, is basically how the computer knows what character to use, what character to display, that kind of thing. And you can go online and search for ASCII tables, and you can put, I mean, there are, so many different characters as you can put in here. It's crazy, just with using ASCII code. So if you have to use a character that's not on your keyboard, you would look up the ASCII code and use that ASCII code for it. So that's how you use that one. And a character uses 2 bytes of space in RAM. Now, the next data type is very common. It's called a Boolean. And a Boolean is either a true or false value. And basically, whenever you're coding, programming, you can think of a Boolean as an is or isn't. So it can get kind of confusing. This is where logic starts to really take over. It's a really huge part of programming logic is the Boolean. And to declare a Boolean, you just write Boolean, B-O-O-L-E-A-N, and you give it a name. This one's B1, and then you assign it a value, and it can only have 2 values. It can either be true or it can be false. It can either is or isn't. And another thing about the Boolean, since it's an either is or isn't, it can only have one value, one or the other value. It only uses 1 bit of space. And if you understand what bits and bytes are, 1 bit is a single binary character in RAM. So it's either a 0 or 1. A 0 is false, a 1 is true. So that's primitive data types. You will see these a lot during the course of these lessons. And in the next lesson, we'll talk about non-primitive data types, what those are and how we can use them, and start talking about classes and stuff like that. Anyway, thank you for watching, and as always, have a good day, good night, whatever it is, wherever you are.